Hi Year 12, here's our fourth lesson for the topic of transformations. In this lesson, we're going to look at combinations. So far we've reviewed how to graph functions, and then we've looked at translations, dilations, and reflections. So of course we can put all of these transformations together. In one equation, we can combine translations, dilations, and reflections. The equation of a transformed function is y is equal to k multiplied by f of a and then x minus b in brackets plus c. The k, of course, is a vertical dilation, scale factor k. The a is a horizontal dilation, scale factor 1 on a. The b is a horizontal translation, b units to the right. And c is a vertical translation. So let's start with a past HSC question. The graph of the function f of x is equal to x squared is translated m units to the right, dilated vertically by scale factor of k, and then translated 5 units down. The equation of the transformed function is g of x is equal to 3x squared minus 12x plus 7. Find the values of m and k. So what we're going to do is apply these three transformations to f of x is equal to x squared. The first one is a translation of m units to the right, so that means putting the m in with the x in brackets, like this. Then we're going to dilate it vertically, scale factor k, so the k comes here, and then translate it 5 units down, so we're subtracting 5. Now this is g of x. It's equivalent to 3x squared minus 12x plus 7. So let's expand this out and tidy it up. X squared, take away 2 times m times x plus m squared. And then expanding through the brackets, we're going to get kx squared minus 2mkx plus km squared minus 5, and this is equivalent to 3x squared minus 12x plus 7. Now we can equate coefficients of like terms. So can you see that k is equal to 3? And negative 2mk is equal to negative 12. We know that k is equal to 3, so negative 6m is equal to negative 12, therefore m is equal to 2. Now this whole video is going to be about the order of transformations because order can be important. Consider the function f of x is equal to x squared. Write the equation of the transformed function g of x. If f of x is dilated vertically by a scale factor 2, then translated vertically 1 unit upwards. Okay, dilated vertically scale factor 2 means put the 2 in front of the function, so 2x squared. And translating vertically means add 1 to the end. So g of x is equal to 2x squared plus 1. Now let's do those same transformations in the opposite order. So we're going to translate vertically 1 unit upwards first, and then dilate vertically by a scale factor of 2. So translating vertically 1 unit upwards means x squared plus 1. Now dilating vertically by scale factor 2 means take all of this and multiply by 2. So g of x is equal to 2 outside of x squared plus 1 in brackets. Can you see? They're different. So order can be important when there are multiple transformations. So if the order is not stated, then the general rule is to do the dilations first, followed by the translations. And remember, dilations will include reflections. Here's our first example. A new function g of x equals 1 minus f of 2x is formed from the function f of x. Describe the transformations that have occurred. So there are 3 of them. We can see a vertical translation, there's a reflection in the x-axis, and there's a horizontal dilation. So there's 2 dilations, we'll put those first. Horizontal dilation scale factor of half, vertical reflection in the x-axis, and vertical translation 1 unit upwards. B. The coordinates of a point lying on f of x are 2, negative 3. Find the coordinates of the image point. So we're just going to apply those 3 transformations to this point. We'll start with the x coordinate because there's only one that affects it, and that's this horizontal dilation scale factor of half. So the 2 is going to become 1. There are 2 transformations that affect the y coordinate. There's this translation, and here we have the reflection, which is a dilation. This one has to go first. So we're going to take our -3, flip it over the x-axis, so it becomes 3, and then we're going to add 1 to it. So it's going to end up being 4. Now just to hammer home the point, have a look what happens if I do it in the opposite order. So I take my -3, and then I add 1, gives me -2, and then I flip it over, I'm going to end up with 2. So this one is wrong, this one is correct. The image point is 1, 4. Let's have a look here. Here's an example of a function, this red one here, that has a point 2, -3. Now all I've done in Desmos is just formed g of x out of this one here. There's our two options, the 1, 4 and the 1, -2. You can see when I do the dilation first, the point actually lies on the transform curve, whereas when I do the translation first, it doesn't. So what I want you to take away from this is do the dilations first. So let's have a look at some different combinations of transformations. Given the graph of y equals h of x, sketch the graph of y is equal to -h of x over 2. So we have a reflection in the x-axis, and we have a vertical dilation of a half. This is going to squish it down. Order is not important here. I'm going to squish it first and then flip it. Now, what have we got here? We have two translations. We have a horizontal translation, 1 unit to the right, and a vertical translation, 1 unit up. Again, order is not important. So I've shifted it over to the right and then up 1. How about h of -x plus 1? So again, two transformations. We have a reflection in the y-axis and then a vertical translation up 1 unit. So let's reflect in the y-axis and move up 1 unit. And y is equal to h of 2x minus 2. Now we have two horizontal transformations. And in this situation, you should always factorize. And this will stop order being important. So this is a horizontal dilation scale factor of half. And then we have got a horizontal translation 1 unit to the right. And I would encourage you to do that one in the opposite order. So translate it first 1 unit to the right and then do the scale factor of a half, and you'll actually get the same answer. So here's a past HSC question. Which of the following represents the domain of the function f of x is equal to ln 1 minus x? So we'll start by quickly sketching ln x and figuring out that its domain is everything from 0 to infinity, but not including 0. Now, just like I did in that last question, I'm going to factorize in these brackets. So ln of 1 minus x is the same as ln of negative, and then in brackets x minus 1. Make sure that makes sense to you. So I have two transformations. I have a reflection in the y-axis, and I have a horizontal translation 1 unit to the right. Okay, so this is going to reflect over the y-axis and then shift 1 unit to the right. It's going to end up looking like this. And our domain is going to be everything from negative infinity up to 1, but not including 1. So our answer is D. Okay, we're going to finish off by doing a question that's quite tricky because we're going to be working backwards. Remember this question? We did it earlier on. New function g of x is equal to 1 minus f of 2x is formed from the function f of x. And we described the transformations that had occurred. There was a horizontal dilation, a reflection in the x-axis, and a vertical translation. Here's the question. The coordinates of the image of point xy are 1, 4. Find the coordinates of the original point. All right, so up here I have got the transformations that the point went through. And you might notice that this is the answer to the previous question. So we're trying to get back to the original point, which was 2, -3. So what we're going to do is go through these transformations in reverse order. And a vertical translation 1 unit upwards is going to become downwards. And scale factor half is going to become scale factor 2. All right, let's start with the x coordinate like before, because there's only one transformation that affects it, and that's that horizontal dilation. So I'm going to take my 1 and I'm going to double it. There are two transformations that affected the y-coordinate, this dilation here, the vertical reflection, and the vertical translation. Now, when we were going forwards, we had to apply our dilation first and then our translation. Going backwards, we're going to do them in the opposite order. So I'm going to start by taking my y-coordinate and translating it 1 unit downwards. That's going to give me 3. And then I'm going to reflect it over the x-axis. And so the original point was 2, -3. Okay, that's it for this lesson. Now this was quite a tricky lesson, so I want you to spend some time consolidating what we've learnt. Our last lesson for this topic is applications.